Right, the purpose of this video is to try and work out through the diagnostics in the 2305 what's the problem with the unit. Now, I'm taking out my depth here, to be honest with you. I think I've bitten off more than I can chew. This is the Marconi that's normally on the rack of units to my left when I'm normally working. This is the unit I'm actually looking for the problem with. Now, this unit's got a problem with it as well, but at least its AM detection circuit works. So what I'm trying to do is also use this as a comparison. Now, one of my YouTube viewers has helpfully sent me some information through, and that's the DEFPOM. I think that's how you say your handle. Has sent me some interesting and useful comparisons between his 2305, so I can check mine in comparison, and I've already come up with a few problems. The first problem, actually, the very first hurdle, I've fallen at the very first hurdle, the input level. He's told me to set my generator to -10 dBm. And -10 dBm is the equivalent of about, I think it's 0.1 milliwatts into a 50 ohm load, or whatever load you're using. So straight away I couldn't work out what that was, because the Marconi hasn't got a dBm calibration, but the Rohde-Schwarz has, and I'm not sure how accurate the Rohde-Schwarz calibrated scale is. And also the problem with the Rohde-Schwarz is I need to run 100 megahertz, and I can't run that high on that signal generator. So what I've done is I've looked at the output on an RMS meter, my HP 3400, to get the level right on that meter, and then connected up the Marconi and increased to 100, set the voltage level to the same point on the Marconi as it reads on the Rohde-Schwarz with the meter, and then just increased the frequency to 100 megahertz. So I think I'm at about the right level. The input level is about right. Now these tests here are basically to test the performance of the unit, and the first test is you have to go into a special function mode. The special function mode will allow you to test this meter here into a DVM reading, to look at the outputs of various stages on the instrument. So what I'm going to do now is I'm going to enter the first one, which in this will be looking at the peak negative reading and the peak positive reading on the somewhere in the unit. I'm not entirely sure where it's looking at. I imagine early on in the front end. So what I'm going to do then, I'm going to do that now. So I'm going to. This is the instrument we're interested in. So you go into special function 8. So you press enter 08, and the last digit for this test is 0. And this is the figure here. Now, according to him, that figure should be about 3,500. It clearly isn't. It's only 286. If I enter it on this one, and this seems to be intermittent on this one. 1 minute it reads better than, and other times it doesn't. And I know this unit's got a problem as well. Okay. And see, it's all over the place on this meter. Now everything's right. I'm using 100. Oh, carrier frequency is wrong. I haven't set there for carrier frequency. Bear with me. 100 megahertz. The modulation is on. 100% deviation. You see these figures are sort of all jumping all over the place, so at least they're sort of a bit closer than the other ones were, but I don't know, there's something still. I think both of these units are faulty, and I think probably this one's got more faults than I realise, and this one's just obvious because the AM detection is not working. So we'll move to the next step. So enter 081. Yeah, and we lost. Enter 081. And that's your negative reading, and that should be about 3,500, and that's not. So let's go to the average detector. Enter 082. That should be about 3,500, and you can see it's not. Next step is 3, which you need to increase the power level for, so I'm going to miss that one. IF level detection. Enter 084. That should be 1000. It's really about 590, 600, so that's low. 085, and the fire should be about 250. That's okay. That's okay. That's the 0 reference. 086. 086 should be about 600. That's about 370. So basically, all the levels are low on this instrument, and I'm not sure why. And I was hoping to sort of get some sort of help by swapping boards in and out of here, but I really don't know where to start. I wonder if it's a job for a total recap, but that's where I am at the moment. Any help would be appreciated. Been going through and checking various other parts of this 2305. What I've done in the end was I swapped the boards from the good unit out to the bad unit. I've actually now managed to get my originally good units that was failing on LF amplifier. I managed to get that to work properly by replacing one of the boards, swapping it out from this unit that's actually was initially planning on repairing, but then found the other one had packed up. So at least I've got one unit working properly now. So we tracked it down to, despite it being a problem with the AM board, it's actually a problem with the FM. A problem with the AM detection. It's actually a problem with the FM board. And I think I've just found what it is. When I swapped the FM board out, I got AM readings and modulation reading correctly. Now this is the FM board. It's pretty straightforward, not a lot to it. And you can see here, this is where the signal comes in from the AM board and feeds into this amplifier demodulator. So basically, that's basically like a demodulation stage of a radio. Nothing particularly fancy about that. You feed your signals in here, and you'll get this is your IF signal, standard 1.5 megahertz IF signal, and then your modulated signal should be on the top of that. I'd expect that's what I'm looking for. So if I look at the input of this op amp here, which is this pin here, there's our very strongly modulated AM signal from the Roden Schwartz feeding into the front panel, and that's present at pin 14 of the chip down here, as you can see there, and you can see it's been filtered slightly, and then you'd expect to see that on pin 10 and pin 6. So pin 6, nothing, just the IF, nothing else. Pin 10, exactly the same, just the IF. No, it's not, the detector doesn't seem to be working. Okay, so what we'll try then is we'll try the FM, modulating with FM. So we'll look on the input of the chip again, which is pin 14. There's our modulated signal there. You can see quite a wide deviation. And I'm going to look at the output of the chip again, so pin 6. And you can see there it is modulated. That's good. And pin 10 is modulated. So it looks like this detector chip should be detecting AM and FM. It's obviously detecting FM okay, but it's not detecting AM. And I think that this is the problem. This chip's probably not working properly. Now everything else seems fine around here. These are basically the rest of the circuit comprises of low pass filters for different frequencies and things like that. All the waveforms here on the schematic look exactly the same as they do in real life. You know, when I check them, they look fine. So I don't think that's going to be a problem. So what we're basically boiling down to now is it looks like it can't be a lot more wrong with it than this anyway. I've checked all the transistors, they're okay, all the diodes seem okay. There's this rectifier circuit here, all that looks to be working fine. The waveforms are right. as far as I can tell, these relays are switching and there's no problem there. So I'm going to go with this TBA 120S chip. Change that, and with a bit of luck we should have AM detection. Thanks for watching. Okay, I found the problem with the AM detection. As I found out when I changed the FM detector board, I managed to get AM back, and it's a simple reason. First of all, I thought it was this detector chip that is up here. This is the detector chip, and basically that's just an FM detector, that's all that is. I thought initially that was doing the AM detection as well, but it's not. If you feed a FM signal in here, you get the demodulated signal here at the IF frequency, which is what you'd expect for a demodulator. So checked all this out, all looked okay. Now this is the problem here. We've got these 3 read relays here, 1, 2 and 3. This one here is basically just a low pass filter, so when this transistor is activated, when this point, if this point is pulled high, that grounds that transistor, so that goes low and turns that transistor off, but it turns this transistor on, and turns this relay on. So what was happening is when you turn that on, that brings these capacitors into play, and that's your low pass filter here. It turns this transistor, this is at 5 volts, so if you bring that line high and turn this transistor on, it turns this relay on, and it puts in this series 2R2 resistor and shunts out basically all this filter network here. So one way it filters, shunts out the other way, and the other way, and it pulls in these capacitors. So basically that's how that's working, and that circuit worked absolutely fine. It's pretty straightforward really. The problem is with here, this was a bit more difficult to try and work out what was going on, because I needed to buzz out or check continuity between connections to see what was going on. And with the unit unpowered, I wasn't getting any continuity from this. This is X1. This is like a little, just like a lead through, and I was connecting my meter to there. And when I connected to this PLCF, which is the connector on the PCB board, I had no continuity. So I thought maybe that's because the unit's not powered. So I checked to the collectors of these 2 transistors here, and there was no connection there. So straight away that's starting to say there's something wrong with this relay. Now the relay does activate. I've checked the voltage, and you can actually hear it clicking if you listen to it. So I powered up the unit again, and as it was running through a calibration test, I measured with the resistance between here and the collector again, and I had continuity. So it showed that the relay was working fine in that direction. So I waited for the calibration process to finish, and then checked the reading again, and sure enough it was still connected to this point here. So what I did was I tried selecting AM/FM and then lost the connection, so it went open circuit here, but never regained the continuity back to PCF. So basically what it does is it routes through, this is from the AM board, and that feeds the audio from the AM and feeds it out of the unit. That was the link. That's what the problem. That's why I had no AM detection, because this connection isn't being made on the way through. The FM side works fine because it comes through here, through the demodulator, through this charge pump, through these filters and out. Works perfectly, but not this way. This contact here is boogered. So what I've got to do now. And I actually proved that. I shunted the connection from there to there, and straight away AM modulation was being shown on the display. So the thing to do now is I'm going to take the board apart just to have a look underneath. What I have also done, I've had limited success with it, is these relays, because they don't often charge a lot of current, take a lot of current, you can sometimes stick a little bit of current through them just to try and clean the contacts up. And what I could do without the risk of running too much is to stick a 50 volt mega across here and just see if we can burn these contacts clean. The other thing you can do is run a demagnetizer on the relay itself, and sometimes just the vibration shakes a bit of carbon off the contact or something like that. But I tried with the demagnetizer, that hasn't worked. So I'm going to take the board apart, have a look at it. If I can't see anything obvious, and it looks like the relay's kaput, I'll get another relay. But that I think that basically sums up fixing the spares unit. It should, apart from now that because I swapped the when the board's out for my good unit, so I've got my other unit working properly. I'm slightly low on gain on the LF section of the amplifier, but it will certainly work properly now. It's just a slight calibration error. So let's get this problem sorted out, and if I feel brave enough I'll move on to the next stage. Okay, what's going on here is this is the relay. I've soldered the back of the relay. I'm applying a voltage from my external power supply to activate the relay on and off. Now that contact was totally open circuit, and it doesn't even measure in the gigaohms on a normal LV meter. So what I've done is I've catch up this isolation tester between the two contacts, and what I'm doing is applying higher voltage than the relay is designed to work at. And what I've done is so if you listen now, if I turn the relay on and off, the contact's working fine. So what I did was I applied 250 volts and turned the relay on and off, and basically what that does is it cleans the contact. It gives it a little bit of current passing through and a bit of a burn, and it seems to be okay at the moment. So let's put it back into the HP and the Marconi and see if that's fixed the problem. I don't know how long it's going to stay reliable for, but sometimes all these things need just a bit of a current passing through the relay, and that'll be enough to fix the contacts. Okay, it's the moment of truth for the AM detection. See if it works now. Power the unit up. Wait for it to do its calibration process. Now in theory, if this relay cleaning session has worked, we'll get the error 1 still. That's the problem with the LF amplifier. That's another problem. I'm not so worried about. The problem was getting the AM detection working. And hopefully the cleaning of the relay by applying a bit of voltage and a bit of current through it has burnt off whatever was on there. So let's see what happens. So the Rohde-Schwarz is generating what looks like about a 65% kilohertz deviation, 65% deviation. So okay, there's our error. And my internal clock stopped running again. That's another thing that's got to be fixed. Good old tap usually gets that going again. Okay. Signal 7.5 kilohertz. Come on, you stupid thing. Okay, we're up and running. Now, let's have a look. AM. Flaky, 63%, but it's certainly working, and it's better than it was before. So maybe it'll stay working, maybe it won't. It certainly seems to be okay at the moment. Yeah, ties up roughly what the Rohde-Schwarz says. I'm not sure how accurate that is. It says about 65%. This is 61. So that was the problem. A faulty relay. And the next problem is just to fix the LF amplifier. Anyway, thanks for watching.